What's up? I'm Jacko. Today we're building AI agents. Agents that can call tools, search the web, query databases, and actually do things in the real world. Not just chat, real actions. We're covering function calling, agent loops, planning, and multi-agent systems. Practice everything on dataforall.dev, link in the description. Let's go. Here's the roadmap. 5 sections. First, function calling. How to give a model structured access to your tools. Second, tool integration, connecting agents to APIs, databases, and file systems. Third, agent loops, the React pattern, reasoning plus acting in a cycle. Fourth, planning and reasoning, how agents break complex tasks into steps. And fifth, multi-agent systems, multiple agents working together. Function calling lets an LLM decide when and how to call external tools. Here's how it works. You define a tool as a JSON schema, name, description, and parameters. The model reads that schema at inference time. When it decides to use the tool, it outputs a structured JSON call instead of free text. Your code runs the actual function. The model never executes anything itself. Schema design matters a lot. Vague descriptions cause hallucinated arguments. Be explicit about types and constraints. Let me show you what a tool schema looks like. It has 4 parts. Name. Use snake case verbs like get weather or search database. Description. This is what the model reads to decide when to call the tool. Write it like documentation. Parameters. JSON schema format. Define types, descriptions, and mark fields as required. If you don't mark them required, the model might skip them. Output. Your code runs the function and returns the result back to the model as a tool message. An agent is only as powerful as its tools. 4 categories. Web and search APIs. Google search, weather APIs. News feeds, any REST endpoint. Databases. SQL queries. Vector database search. Key value stores. Graph databases. File systems. Read and write files. Code execution, shell commands. Services and SaaS. Email, calendar, Slack, Notion, GitHub, Jira, payment APIs. The more tools you give it, the more it can do. 5 patterns that make tools reliable. Tool granularity. Narrow tools are safer than broad ones. Use search by ID instead of query database. The agent can't inject SQL it can't write. Error handling. Always return structured errors. The model reads the error and can retry or pivot. Silent failures cause infinite loops. Side effect safety. Separate read tools from write tools. Gate destructive actions with confirmation. Context injection. Keep tool outputs concise. Large blobs eat your context window. Auth and secrets. Never pass credentials through the model. Your code handles authentication. React stands for reasoning plus acting. This is the core pattern for agents. 4 steps in a loop. Step 1. Thought. The model reasons about what to do next. Step 2. Action. It calls a tool with arguments. Step 3. Observe. The tool result is added to the context. Step 4. Repeat. The loop continues until the model has an answer, hits the max step limit, or emits a stop token. When should the loop stop? Good stops. The model outputs a final answer with no tool call, or it signals task complete. Bad stops. Max iterations exceeded. Repeated tool calls with the same arguments. That's a loop. Error threshold reached. And the most important one. Human in the loop pause for confirmation before destructive actions. The pseudocode is simple. Loop up to max steps. Call the LLM. If no tool call, return the response. Otherwise, run the tool, append the result, and loop again. Complex goals require the agent to plan. Example. User says research competitors and write a summary report. The agent decomposes this into 4 steps. Step 1. Search the web for competitors. Step 2. Fetch each competitor's page. Step 3. Summarize each source. Step 4. Write the final report. Each step maps to a specific tool. The agent executes them in order. Well-designed agents check their own work. 3 techniques. Chain of thought scratchpad. Let the model reason step by step before calling a tool. This reduces errors dramatically on multi-step tasks. Self-critique loop. After producing output, the model rereads it with a critic prompt. Does this answer the question fully? What's missing? Then it refines. Backtracking. If a subtask fails, the planner reroutes. Try different tool. Reformulate the query, or skip and mark incomplete. Some tasks are too large for one agent. Divide and conquer. An orchestrator agent coordinates specialist agents. Research agent handles web and docs. Code agent writes and runs code. Writer agent drafts the output. Review agent does quality checks. The orchestrator decomposes the task, dispatches to specialists, collects results, and delivers the final output. 4 patterns for multi-agent orchestration. Supervisor and worker. One orchestrator decomposes the task and dispatches sub-agents. Best for clear hierarchical tasks. Pipeline. Output of agent A becomes input of agent B. Like a factory line. Simple but rigid. Peer-to-peer handoffs. Agents pass tasks based on capability. More dynamic but harder to debug. Specialized experts. Each agent has a narrow domain. A router directs queries to the right expert. Key challenges in multi-agent systems. Shared state. Agents need common memory. A database, scratchpad, or message queue. Context passing. When delegating, include only the context the sub-agent needs. Full history blows the token budget. Error propagation. Sub-agent failures must bubble up cleanly. The orchestrator needs structured error types. Loop prevention. Agents can delegate back to each other. Add depth limits and cycle detection. 4 memory types. In-context messages. External database, episodic logs. And semantic search with embeddings. The complete picture. 5 layers. At the top, the user issues a natural language goal. The orchestrator agent plans, decomposes, and delegates. Specialist agents handle specific tasks. Code agent, research agent, writer agent. The tool layer connects to APIs, databases, file systems, and web search. And at the bottom, the external world. Real data, real side effects, real results. 4 things to remember. 1. Function calling gives models a structured interface to the world. Define precise schemas. Vague descriptions equal hallucinated arguments. 2. React loops are the engine. The model reasons, acts, observes, and repeats. Always add stop conditions. An infinite loop is an infinite bill. 3. Planning quality determines outcome quality. Decompose tasks and let agents self-correct. Chain of thought before action reduces errors. 4. Multi-agent systems scale what's possible. Start with a single agent. Add agents only when complexity justifies it. That's AI agents and tool use. From function calling to multi-agent orchestration. Head to dataforall.dev to practice everything we covered. Build real agents with hands-on exercises. Link in the description. If this was useful, hit subscribe. We've got the full generative AI track covering RAG, prompt engineering, fine-tuning, and more. Happy learning and peace.